Hey guys, remember this build? I hope you do. It's the build I did featuring mostly Corsair parts using Corsair's Hydro X series of custom water cooling components. It is now available for sale.
Excellent!
Deepcool knows that there's more than one way to cool a CPU, so for air cooling fans, they made the Assassin 3, a 280-watt TDP tower cooler that stays chilly and silent with 7 heat pipes, dual 140mm fans, and a polished nickel finish. Or if you prefer water cooling, the Castle 360EX is a 360mm all-in-one with tasteful RGB lighting, exclusive anti-leak technology, and a copper-based custom designed for maximum cooling performance. To find out more about Deepcool's Assassin 3 or the Castle 360EX, click the sponsor links in the description.
So when I say available for sale, I actually mean this is up for auction. That is ongoing, and you can view the description if you want more details on that, and I'll also be covering more of the details when we get later in this video. Short version though, the proceeds are going to go towards charity, and if you happen to be the one who wins the auction to buy this system, you will need to pick it up in person or send a representative to pick it up here in Southern California. That said, today's video is going to be a little bit more testing on this system. I have gotten Windows installed, but I want to see if we can get some system temperatures for the CPU and GPU, maybe do some quick gaming on it just to show what it actually is capable of. And then I just wanted to do another pass at the system because, for one, I have added some more LED strips along the bottom and back edge right here, and right now they're wired outside the case, so obviously that's not acceptable. I want to do a flush of the liquid and the water cooling loop because it's still using the stuff that we put in there originally, and I think it would be nice to flush it out before it gets handed off to the eventual owner of the system. And finally, we got to make sure everything is fully functional, of course. So we've got LEDs in here. Right now they're set to white mode, and I do need to do one bit of troubleshooting because the top 2 LED fans are not currently lighting up. So I might need to wire in another controller to the USB ports. That said, let's get to work. So I got the system set up, and I've got Windows installed, and I've got the iCUE software loaded up, and I'm running hardware info 64 so we can take a look at some initial temperatures, and things are looking okay so far. As you can hopefully tell, I've got the memory dialed into its XMP setting. Here are our current CPU temperatures. The lowest it's gotten is 32.8 C, which is low, could be lower. It's doing something in the background, which is why it's thinking, which is why it has peaked at about 57 C, which again isn't horrible. I'm more curious at how this is going to behave once I actually get a stress test up and running. But I think for the sake of moving forward with what needs to get done today, I'm going to shut this down and start taking this system apart because I think that's mostly what's going to need to happen in order to properly flush this loop out. So we're almost ready to flush the front radiator here, and my basic goal here is to flush each individual part, but I don't want to remove it from the case if I can avoid that because stuff is wedged in here pretty good. Originally the liquid flow was going this way, so that was the inlet, would go through the rad and then out the other side and to the back to the reservoir and pump, but I want to flush it the other way. So on this side I have the tubing going over here to this little SwiftTech pump, and that is going into our little temporary reservoir so it can flush out. And then on the other side, it is going to eject out that way and into the bucket. All I need to do is plug in a little AC power adapter, which has a Molex plug on the other end. That's what I'm using to power the pump. Then I can just turn the pump on and off with the little power switch. So here's where we're at. I am pretty much ready to fill the loop. Everything has been reinstalled, and I think the cable management area in here is way, way, way better than it was before. I left the labels where I taped them on, so those are kind of standing out a little bit, but I feel like functionally those are really convenient to have there if anything does need to be pulled out of here. I added those SATA cables from the very inaccessible point behind the graphics card and routed them back up and just in here to the drive cages. And yes, I saw comments from quite a few of you that this upper right drive cage can be removed, but I really wanted to see if I could leave it in there so that, again, whoever ends up with this system has the ability to add a couple 2.5-inch SATA drives or even 3.5-inch mechanical drives if they want to, and at least the data cables for those are routed up, and it's not too terribly difficult to get at the power cables for the modular power supply down there. So my pump reservoir here is ready to go. I'm going to fill it right here. I just left the power lead coming off of it so I can plug it in and power it on to cycle through the loop, because I'm not going to power the whole system on until I've leak tested once again. Once that's done, I have the Molex plug for it right here, so I'll just plug that right in so it's good to go. And meanwhile, here's a look at the front end again, which hopefully should pretty much be looking the same. I tried to do a little bit more training with the cables down here. A lot of people were concerned about this touching right here. Since the fan has its bracket right there, it is not touching, and I've been spinning the fan just to make sure that it isn't. Beyond that, all the tubes went right back where they should be, so that was nice and actually pretty easy to put back together. And of course, we've now added the LED strips along the bottom edge and the left side here, which, believe me, in just a second you're gonna see, but really helps to balance out everything with the LEDs in the system. The next step was to sort of re-attack the LED setup, because there are a lot of LEDs in this build, and I added even more since the part 1, 2, and 3 original build series, in that I put a strip across the bottom that also goes up the back, and I think that adds a lot better, more balanced light to the entire system. To power that, I had plugged in a temporary Node Pro, but I decided I was gonna need that in order to do it. So in order to get around the LED lighting issue with the top fans not lighting up, I decided to connect all 5 fans to that Node Pro, and then the second input on the Node Pro would control the LED strips. And then I went to the trouble of individually labeling all of the LED leads coming off all 5 fans. And that's because you want to know what order they're in, so you can set them in the right order in the Corsair IQ software, so that some of the lighting effects that go across all of the LEDs, for example, will go in the correct order. One last little detail I wanted to add that I thought of after the original build series was something for additional storage, because right now you've got a single 2TB SSD, which is fine to get you going, but whoever ends up with this might want to add more storage. Making that easy is something I wanted to keep in mind. So I just wired up a couple SATA cables. I used the 90-degree ones so I could angle them off of the motherboard, route them back behind the motherboard tray, and then just pass them through up into this cage area. They're just sitting there right now, but it's a lot more accessible, so a 3.5-inch mechanical drive or a 2.5-inch SATA SSD could easily be installed in these cages, plugged in right there, and you're good to go. So as is hopefully obvious and plain to see, this is a beautiful looking little system. It's small, it is like only about yay tall compared to me. You have me for comparison right here, so hopefully that makes some sense. But none of this means anything unless my efforts make a reasonably functional system, and I assume for those of you who are actually maybe considering buying this, that might be something that you're interested in too. So I was able to do a brief bit of testing. First off, for the graphics card, I just ran Unigine superposition to do a stress test, and initial temperatures were super chilly at about 49 degrees Celsius, crept up to 50, and then it kept going up beyond there. It ended up getting up to about 58 degrees Celsius after several runs, which isn't horrible at all by any stretch when it comes to a 2080 Ti. Usually when they're air-cooled, they run up closer to 80 degrees Celsius. Meanwhile, the frequency for the 3900X was averaging at about 3.9 gigahertz. It actually originally started a little bit lower than that, but I also noticed that initially my temperatures were spiking up a little bit higher. In my opinion, there is an inflection point at 80 degrees Celsius with these CPUs, at which point it will throttle the frequency and dial it back a little bit, possibly even drop the voltage just a touch. So over time, the average crept up from a little over 3.8 to about 3.9 gigahertz, which is what it ended up being after the stress test was running for 10 minutes or so. Now this made me think, what is causing this setup to run warmer when it comes to the CPU frequency in a CPU stress test compared to the test bed that I was running just about a week and a half ago? I think the difference is the case. In this case, the Corsair 280X, if it has been criticized at all, has been criticized most critically for the airflow. The fact is, it has dust filters that come pre-installed, and it also has tempered glass side panels. So because I was running out of time and because I just wanted to see what the difference it would make, I popped off the top tempered glass panel and I removed the top and the front dust filters, and then I let the test keep running, but I just refreshed the averages, and what do you know? Suddenly temperatures dropped, but not by a whole lot. Temperatures only dropped by about 1 or 2 degrees Celsius when it comes to the average temperature for the CPU. What happened instead was AMD and the motherboard decided to run the CPU at a higher frequency. So voltages crept up a little bit and they were going over 1.2 volts. Meanwhile, frequencies were more like 3.95 gigahertz rather than 3.9 or just below that. But that's not the end of the story, of course. You might be looking at this system and being like, well, I could just get an all-in-one liquid cooler and pop it on my CPU and get the same or better results and just run it out of the box. And you're right, you potentially could do that. The benefits you're getting from a setup like this are that it is actually inside a case which does have dust filters, which should collect dust and allow you to clean them over time. Secondly, the front and top panels absolutely block a bunch of noise that comes out of the system, and I noticed very distinctly just removing that how suddenly much louder the system became. And lastly, I am talking about a stress test situation situation, putting more of a load and generating more heat than you will typically generate with a computer like this when you're just doing your typical day-to-day computing tasks or gaming. So I think what you end up with is more of a balance between the frequencies that your CPU and GPU can run at, the overall heat output of your system, the overall noise output of your system, and having something that both looks nice as well as can be easily picked up, moved around, and is relatively protected from, I don't know, flying objects and household pets. So there are a lot of parts in this build, and I wanted to tally them all up, which I don't always do after the end of a water-cooled build, but it seemed appropriate this time. I'm gonna try to go through these pretty quick and tell you how much everything costs at the end. Starting with the processor, Ryzen 9 3900X 12 core. This is $500, not currently available for sale, but I'm gonna call it 500 bucks. ASRock X570M Pro 4 motherboard is $180. The Corsair Crystal 280X currently on sale for $105. Power supply, the SF750 is $180. It is 80 plus platinum after all. The MP600 Gen 4 PCIe SSD, the 2TB version, is $420. That's a lot of money in SSD storage, but it is really fast. Speaking of a lot of money, the memory kit is also quite spendy for this build. The Vengeance RGB Pro kit of 64 gigs, 4x16, that is also DDR4 3600. On the plus side, it plugged in with XMP and is working in the system. On the minus side, it's $600. That's over $1,000 on SSD and memory in this build. Speaking of over $1,000, we have an RTX 2080 Ti. The one that we used is a reference PCB design version, but it's the Asus Dual from Asus, and it currently sells for $1,140. We have these very pretty white Corsair LL series fans. These are 120 bucks for a kit of 3. We used 5 of them, so used 2 of these sets. The Elgato Game Capture 4K 60 Pro. This is the Mark II version, which is smaller and also has support for HDR10. Currently sells for $250. We have a Corsair iQ Lighting Node Pro kit that includes the Node Pro little controller unit there, as well as some RGB LED strips. That's about 50 bucks. For $60, we have the Commander Pro, which is that central unit that has a bunch of the fans connected into it. It also has a temperature sensor that I connected up the temperature lead from the water cooling loop to. That's 60 bucks. I ended up using this Asia Horse sleeved power supply kit, which is only $32, probably the most reasonably priced thing in this build, and it also looked quite nice, so I was happy with it. And that pretty much does it for the main parts in the build, apart from the water cooling, and the total I came up with there was $3,759. Let's see how much the water cooling stuff costs. $75 for the XC7 RGB, which is the water block. Fits both AM4 and current Intel mainstream sockets. 75 bucks. $152 for the Hydro X XD5 pump reservoir combo unit. It does have a D5 pump in there, which is a real nice pump. We have the XR5, which is a 240 millimeter water cooling radiator, 240 millimeter, and we use the slimmer versions, 2 of those for $120 total. XG7 RGB water block, which is also quite fun. RGB light up, and $150 for that. Includes a back plate, so that's nice. We're over on the Corsair website for the rest of these. I have hardline 14 millimeter tubing. I used a couple kits of that. I have this fill port that I used as a pass-through. That's $15. The fittings come in packs of 4, and they're $27 each. I used 8 of these, which was 2, so $54. I also used some soft tubing in the back, so we have this compression fitting. I just used a couple of these, but they come in packs of 4, so that's another 27 bucks. A ball valve for the drain was $20. A couple 2-packs of 45-degree rotary adapters are $27 each. A couple 2-packs of 90-degree rotary adapters are $27 each. Actually, I think I used 3 of those. I couldn't quite include everything here because I used a few fittings that I already had on hand, as well as a couple dual rotary 45-degree fittings that you can't necessarily buy outright. So I'm not even including every single thing that I put in this build in this list, but it's pretty close. Finally, we have that rotary X splitter that I used to split off between the ball valve and the return to the main loop. That's $20. And then of course we've got that performance coolant in there. I just used the clear stuff, and that is $18 per bottle. So add all that up, and the water cooling parts come to about $811, and the entire thing, $4,570 if you were to buy it straight up, and that's not including labor to put it all together, as well as some of the extra little parts that I put in here and there that I might have forgotten, like the temperature sensor for the thing. I forgot to include that, but I'm sure it's there somewhere. So who wants it? This thing is up for sale as of right now. And the way I'm gonna do this is a way that I hope works out. I'm gonna do a silent auction. I have an email address that if you're interested, you should email, please, serious entrants only. And bear in mind, I am going to vet the entrants because I want to make sure that I get a legitimate person. You have to pick this up in person. Ideally, if you're available on November 30th, Saturday, we're gonna be having a fan meetup, and that would be a great time to meet, but I can be flexible and meet with you otherwise. Besides that, I might potentially ask you for stuff to prove you're a real person and that you are who you are. So please be prepared to do stuff like taking a selfie with something written on a piece of paper that proves you are you, possibly even sharing social media contacts or something like that. Again, guys, the entire 100% of the proceeds from this sale are going to go to charity, so I really hope that I don't have to deal with too many scammers, but I'm going to keep my eye out for that, and I hope we can find someone who is local, or at least able to send someone to pick this up locally, who has relatively deep pockets. Because again, the base price here is $4,570. I'm hoping we can go a little bit beyond that. If you are interested, please email me at this email address that you can see on screen right now, paulshardwarehydrox@gmail.com. Please include your full name and address, the amount of your bid, that's important, remember this is a silent auction, and hopefully something to prove you're an actual person who has money to invest in something like this. I'm thinking the best thing would be a link to a Twitter post that has your picture on it or something like that, but feel free to be creative. Just bear in mind, I'm not clicking random links or downloading pictures that are attached. 100% of proceeds, once again, will be going to charity, and if you're wondering which charity, I'm actually going to be making this slightly confusing by splitting it 3 ways. 1/3 of the proceeds will be going towards Donors Choose, which helps teachers and students across the United States, and I will be working with whoever the winning bidder is to choose who on Donors Choose they want to donate that part of the winnings to. This one is all about the kids, again, helping teachers and students in areas of high economic need. And you know, the children are our future and tomorrow and everything. So I really like Donors Choose. They're really, really highly rated as a charity as well. So even if you're not buying this, consider checking them out. The second third of the amount will be going towards Eden Reforestation Projects. This is a charity that was brought to my attention by Steve from Gamers Nexus. They plant trees, particularly in developing and underdeveloped countries that have suffered from reforestation, which helps in a variety of ways, not just being eco-friendly and helping out the environment, but also helping out the people who live around these areas that have suffered from over-farming or from deforestation. And the final third, or actually 34%, will be dropped into the buckets for our awesome hardware charity live stream. We're doing another 12-hour stream on December 7th, coming really soon. Here's a link to the one we did last year where we raised over $20,000. Actually, we peaked at over $25,000. I shaved off my beard. It was epic good fun. I'm gonna once again be raising money for Extra Life, so the Children's Hospital of Los Angeles is where proceeds from that go. So that's where the money from this system is gonna go once I find out someone to buy it. So once again, go ahead and email me at paulshardwarehydrox@gmail.com if you're interested in putting in a silent bid for this system. Again, serious bidders only, please. Thank you all so much for watching. I'll put links to the parts I used for this down in the video's description, and we hope to see you guys on December 7th for our 12-hour charity live stream. I hope it goes smoothly this time, just like it did last year. Thanks again for watching, guys, and we'll see you next time.